All right, welcome back to 13.3. These problems are kind of long and involved, so just take your time. Try not to get frustrated. Watch them as many times as you need to. So 1 liter of water is in a cylindrical container. All right, so let me draw my container. The water is poured into a second cylindrical container whose radius is 3/4 the radius of the first one. Well, 3/4 is smaller, so I know it's going to be a smaller circle. I guess I don't know how tall it is, right? So I know that this radius, let's call it r, and then this radius is going to be 3/4 r. Describe how the water level in the second container compares to the water level in the first container. So let's say maybe it was filled to this point. It had a volume of V. And it's getting poured into here, and I don't know where it's going to go, but it's going to have the same volume. But they want to know how the heights compare. The height of this guy to the height of this guy. How do the heights compare when the water level? So let's take a look here. I know that this volume is going to be, well, it's the area of the base, so that's pi r squared times h1. And this volume is going to be pi, now the r is 3/4 r squared times h2. And I know that the volumes are equal because we just poured the same amount of water in. So I'm going to set them equal to each other. So my first one is pi r squared times h1. And that's equal to, and I'm going to square each one of these. So 3/4 squared is the same as 3 squared over 4 squared, which is 9/16. So this is going to be times 9/16 r squared times h2. So now I'm just going to kind of clean this up. I've got a pi. I can divide both sides by pi r squared, pi r squared. So those are going to go away. So I've got h1 is equal to 9/16 h2. Now they want to know how the height of the second one compares to the first one. So another way would be to multiply both sides by 16/9 to kind of see how do they compare this way. And it doesn't really matter if you were able to see it, but what I can see here is that this is more than 1, right? 16/9, it's more than 1. So the second height is more than 1. It's greater than height 1. Because if, let's say this was, 2, it'd be 2 times this number. It would give me bigger. So I can say that height 2 is taller by 16/9. Let's look at another example. A cake recipe will make a round cake that is 6 inches in diameter and 2 inches high. If you use the same recipe but pour the batter into a round cake pan that is 8 inches in diameter, how tall will the cake be? All right, so let's start here. So I've got a cake that is 6 inches in diameter and 2 inches tall, and I'm going to pour that into a cake that is 8 inches in diameter, so that's a little bit longer. Right, this is 8 inches in diameter. And how tall will it be? We don't know. So we're going to use the same recipe. So the volume doesn't change, right? So let's see here. So the volume here is going to be the area of the base. So remember, the diameter is 6, so the radius is 3. So pi r squared, pi 3 squared times 2. So that's going to be 9 times 2 is 18 pi. And then this volume here is going to be pi, it's 4 squared because it's 8 is the diameter times we don't know h. So this is 16 pi times h. Now we know that the volumes are the same, so we can set them equal to each other. It's the same recipe. So we can divide both sides by pi. That's going to cancel out our pi. We get 18 equals 16 times h. We're going to divide both sides by 16. So we can see that the height is 18/6. Or maybe you prefer 1 1/8 inch. Same idea. All right, suppose you want to use the same cake recipe to make a rectangular cake. If you use a rectangular pan that is 8 inches, so let me draw this, rectangular pan that is 8 inches wide by 10 inches long and 2 inches tall. how much of the recipe should we need? So is it going to be twice the recipe, 3 times, half? How much of that recipe? So first, how much cake fits in here? What is the volume? Well, I know it's going to be the area of the base, 8 times 10, times the height is 2. So the volume for this recipe is going to be 160 cubic inches. So how does that compare to this volume, right? This is the original recipe. So that volume, how many 18 pies can I fit into 160? So it's 160 divided by 18 pi. That's going to tell me how much. So when I divide it, I get about 2.8. So we could say about 3 times the recipe. About. Maybe you don't like that rounding. Maybe you want to say 2.5 because you don't want the cake to overflow. I think that's also valid. All right, let's take a look at another example here. So the front and back of a greenhouse have the shape and dimensions shown here. It's 40 feet long, so they don't show us that. And the angle at the top is 90 degrees. A fungus has begun to grow in the greenhouse, inside the greenhouse. So we need it to be sprayed, and it's sprayed into the air. To be effective, 1 tablespoon is needed for every cubic yard of volume. How much fungicide should be used? And we've got to give it in practical terms. Okay. Let's move this one over. Okay. So we have to figure out the volume. So the volume is always the height times the area of the base. So what's the base here? Well, this is a greenhouse. It looks like this, but it's also a prism. So it's going to have, both sides kind of going back here. So do you see how this kind of looks? That was not a beautiful picture, but the idea is that this is the base right here. So let's find the area of this base. This is clearly a rectangle. This is how I'm going to look at it in a right triangle. So I know that the area of the base is definitely going to be 9 times 12, right? So the area of the base is going to be 9 times 12 plus this triangle. So this is 12. Now, if this whole height is 15 and this is 9, so what's left over here is going to be the height of my triangle. 15 minus 9, I've got 6 left over here. So that's going to be 1/2 base times height. That's the area of that. What's the height here? Well, it said it was 40 feet long. I know we don't normally think of long as height, but that is the height if I were to put this kind of shift the dimensions. So it's going to be, this is my volume. So when I type all that into my calculator, this is going to be like 108 plus 36. So it's going to be 40 times 144. This volume is 5,760 cubic feet. Now the rest of this problem is not about volume. So if that's what this section is on, volume. But now we're going to do conversions, okay? So we want to say here, what do we know? First of all, we know that 3 feet make up 1 yard. So what about cubic feet? So I'm going to cube these. So I'm going to get 27 cubic feet fit in 1 cubic yard. So let's divide our cubic feet by 27 to get it into yards. So when we do that, we get 213.3 cubic yards. All right, so now we need to split this up here. We want to know how many tablespoons we need. So we have 16 tablespoons go into 1 cup or 8 ounces. So how many 16 tablespoons? Well, we know that there are 4 cups in a quart, so let's multiply this by 4. So that's 64, because 16 times 4. 64 tablespoons are in 1 quart. So let's divide this by, let's get it into quarts. So 213.3 divided by 64 is going to give me 3 1/3 quarts. So now I need to figure out this 1/3 quarts business. So 1/3 quart is how many ounces here? 1 quart is 8 ounces. So what is 1/3? One quart is, we multiply this by 4, so this is 32 ounces. So 1/3 quart is 32 divided by 3 ounces. So that is going to be 10 2/3 ounces. So now I've got this 2/3 ounces. How can I rewrite 2/3 ounces back into tablespoons? So let's go back here. If 16 tablespoons are in 8 ounces, let's divide this by 8 to get it into 1 ounce. So that's going to be 2 tablespoons in 1 ounce, so 1 tablespoon in a ½ ounce. So we can call this about 1 tablespoon. So, oh Lord, let's see. We got 3 quarts. And then we got 10 ounces and 1 tablespoon. We're going to pause there, and when we come back, we'll do another couple examples.